if we miss a Monday or another random day that we're not meeting, I am going to make a short video. I want to get in the habit of doing this. We're losing so much time every week, so this is my way to kind of make up for it. Also, it's just going to keep things in a nice, organized regimen. What's the word? Schedule? Sure, schedule. It's a little late, and I'm a little sleepy, so forgive me. But when I post this, I'm also going to post the PowerPoint that goes along with it. And the PowerPoint that goes along with it is called Basic Properties of Algebra. It's going to be dated either Monday the 7th or Tuesday the 8th, depending on when you look at it. But the first thing I would ask you guys to do is the do now, and it's just simplifying expressions. So this is the do now. 3x plus 7y minus 10 minus 2y minus 18x plus 4. I'm hoping you'll look at this and say, oh, this is easy, simple, like, I have no issues with this. And that's where we should be. And if not, that's where I come into play. So the first thing I like to do is I actually like to go alphabetically. So if I notice that I don't have, like, any, like, x to the second or x to the third or y to the second or blah, 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 I'm just going to deal with my x's first. So I have 3x, that's a positive 3x, and the only other x is this negative 18. And remember, the sign that's directly to the left is the sign that carries with it. So this is going to turn into negative 15x. So I've dealt with my x's, now I have to deal with my y's. This is a positive 7y and a minus 2y. No other y's, so 7 minus 2 is 5. And then last but not least, I'm going to deal with my constants. And my constants is just like a fancy way of saying with numbers by themselves. That's going to be minus 10 plus 4. So negative 10 plus 4 gives me negative 6. And that would have been the do now. Great. So, first things first, when we combine like terms, and I'm going to blast through the PowerPoint, do all the examples that are on the PowerPoint on this board, and then hopefully this will be like a 10-minute video, but with the way I talk, it's probably not. So you can only combine terms that have the same variable and power. So on the next slide, I have 4x plus 5x squared plus 10x plus 4x squared. So let me look at myself, make sure you guys can see. Okay, so I can't combine x with x squared. I just can't do it. They don't have the same power. But I can combine my x squared with my x squared. That's going to give me 9x squared. And I can combine my 4x with my 10x. That's going to give me 14x. And then you're done. That's it. So I have a little example for you guys to do. It is, why would I give you that example? That's an easy one. 5x minus 4 minus 2x plus 13. So again, you would just combine 5 minus 2 is 3x. Negative 4 plus 13, I want to say it's 9. So it should just be 3x plus 9. Easy peasy. Okay. I know you've learned distributing before, but the way that I teach distributing, I call it the swoosh swoosh. So if you saw something like 2 times 3x plus 4, with 3x plus 4 in parentheses, I call it the swoosh swoosh because you literally go swoosh swoosh. I'm going to do 2 times 3x, gives me 6x. I'm going to do 2 times 4, 8, and you're done. You did your swoosh swoosh, you distributed, and that's as simple as it is. I give you one to try. So the one that I have for you to try has a negative. It works the same exact way. Distribute the negative. So we have negative 8 times x plus 3. Swoosh, swoosh. Negative 8x, negative 8 times positive 3 is negative 24, and you're done. So I would then ask you to kind of put it all together, and we will do both examples. So the example I have is 4 times x minus 2 minus 5x plus 15. First things first, we have to distribute. So I'm going to go swoosh, swoosh, and I'm going to rewrite this. 4x minus 8 minus 5x plus 15. I just bring this part down, or just brought it down, and now I can combine like terms. 4x minus 5x is going to give me negative x. If you put negative 1x, I would never ever take points off for that. I think that would be a silly thing to do, because negative 1x and negative x are literally the same thing. I like to keep things as simple as possible, so I do it without the 1. But if you write the 1, that's totally fine. And then last, I have negative 8 plus 15. I want to say that's 7. And then you're left with that. Ooh. I give you one to try. That is a lot longer. But we'll do that together. So it's negative 3 times 2x plus 3y minus 1 plus x plus 11y minus 13. And I do believe I put the answer underneath in the PowerPoint, but I'm going to show you how I do it. I'm going to distribute first, so you can see the full equation. Negative 6x minus 9y plus 3. Be careful, when you're doing negative times negative, it makes a positive, so please be aware of that. And then I'm just going to bring everything else down. And then combine like terms. Again, I'm going to go alphabetically. Negative 6x plus x is going to give me negative 5x. Negative 9y plus 11y is going to give me positive 2y. And then 3 minus 13 is minus 10. I have a sneeze. Thank you. Okay, last thing about distributing. I wanted to have an example of, it's been called so many different things. So if you see two binomials and they're being multiplied together, it's probably referred to the most as foiling. And you can totally say foiling, that's okay. We're trying to use the word distribute more because you could have like a trinomial and a binomial and have to distribute every single piece. But when it's a binomial and a binomial, I like to say you gotta swoosh, swoosh, and swish, swish. I will write the example. So the first one I do is really basic, x plus 1, x plus 2. I'm sorry, I should say x plus 1 times x plus 2. And I'm going to swoosh, swoosh. So I'm going to show you my lines. I'm going to go swoosh, swoosh. I'm going to write that down first. So x times x is x squared. X times positive 2 is 2x. And then I'm going to swish, swish. You get 1x, and then you get 2. And I'm going to combine like terms. And again, I could have just totally written that as x. And that's distributing. That's foiling. That's swoosh, swoosh, swish, swish. That's whatever you want to call it. But please note that that is distributing. That is the correct term to describe it. But in class, I will definitely say you gotta swoosh, swoosh. I give you one to try. And this one I want to do because it involves different signs. So this one is x minus 4, x plus 6. Am I right? I am right. So we're going to swoosh, swoosh. X squared plus 6x. And then we're going to swish, swish. Minus 4x minus 24. And then combine like terms. Ta-da! That's it for distributing. What I'm going to move on to now is the power rules. And I am a sucker for power rules. I love them. For some reason, I've just always had such a fun time simplifying expressions using these rules. But for example, the first one is just multiplying two terms together. So if I had x to the 4th times x squared, I do not multiply these together. If it's simple multiplication, and it doesn't even need a little dot in the middle, if it's just x4, x squared, x to the 4th, and x squared, you're just going to add them. And you're going to get x to the 6th. And the reason why this works is because x to the 4th is x times x times x times x. And x squared is x times x. If you were just count them up, there's 6 of them. So if it helps to write it out so you know not to multiply them, feel free to write it out. I'm never going to tell you not to do something that works for you. Always do something that works for you, and if you need that visual, that's great. So the example that I left for you is x to the 3rd times x to the 7th. We're just going to add them. X to the 10. Easy peasy. So when they're multiplied, we're going to add. And when they're being divided, we're going to subtract. Yay! And I have a thing with 3s. When I have to pick a random number, I usually pick a 3. So I might use 3 a whole bunch. You'll get used to it. It'll be fine. The first example is, that is not the first example. Here it is. First example is x to the 10th. Here's the bottom. Divided by x to the 3rd. And with division, you're just going to subtract. X to the 7th. Ta-da! If you need a visual, I shouldn't have picked 10 and 3, but I'm going to do it. So x to the 10th is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's. And then x to the 3rd is 1, 2, 3. And if something is in the numerator and also in the denominator, we can cancel them out. And then we're left with 7 x's, which is x to the 7th. The example I leave for you is y to the 6th divided by y squared. And again, my natural instinct is to just divide the two numbers, but don't do that. That's my natural instinct too. I want to divide it, I want it to be y to the 3rd, but it is not y to the 3rd. It is y to the 4th, because you're just subtracting. Great. Another thing you should know is negative exponents. Now, when I was taught negative exponents, I was taught jump the line and change the sign. And I will say that forever, because I love it a lot. Negative exponents, and I forgot I said this last year, just mean that you're powering the reciprocal. So this is what I mean by jump the line and change the sign. So if I had 1 over x to the third, 1 over x to the third, I believe this is the proper way to keep it, but if you wanted to be fancy and you were like, I hate fractions, I don't like fractions, I don't want to look at fractions, what you can do is you can bring him, you jump the line, so I bring him up here, and I change that sign. So this would then equal x to the negative third. This is the same exact thing. If I had x to the negative fourth, and I said, ugh, I hate negative exponents, they look disgusting. Here's what you can do. Since everything is over an invisible 1, right, I can jump the line and change the sign. And this is the same thing as 1 over x to the fourth. That's it. They're the same exact thing. So just to make it look cleaner, I'm going to rewrite it without all my work. So x to the negative fourth is 1 over x to the fourth. 1 over x to the third is x to the negative third. There's a little, you can see the screen, so I'm going to put it here. Yeah, that's it. Very last power rule is putting a power to a power. And this is when you multiply them. So I have 2 examples. The first example, again, involves, they both involve 3's. X to the fourth to the third power. 4 times 3, 12, done. If you like visuals, I'm going to make this a visual. So this is x to the fourth 3 times over. So I'm going to have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. That's a lot of x's, but that's why it's 12. I then ask you to try x to the third to the 5th power, which is just x to the 15. I'm already approaching 20 minutes. I'm so sorry. But at least it's not an hour of class. So, last thing I'm going to do is 2 more examples by putting all of our skills together. So the very first one that I have, x to the 4th, y to the 5th, 3rd power. And then I get a little fancy. I have some negative exponents. 3rd to the 2nd power. This looks like junk. First thing you need to do is you need to deal with the power to a power. Because if you think about PEMDAS, P, parentheses, and then it's E, exponents. So these, yes, they have parentheses, but the purpose of the parentheses is the exponent. So do your exponents first. I'm going to rewrite the top and the bottom. X to the 12th, y to the 15th, over x to the negative 4th, y to the 6th. And then what I'm going to do is I'm going to use my division to get rid of it. So 12 minus negative 4 is actually 16. We're here, so 12 minus negative 4. And then 15 minus 6 is 9. That's all. It appears that, though, on the PowerPoint, I was missing a division sign. So let me see if I can fix that really quick. I probably can. I I can. Okay, so the problem that I had for you to try is x to the 5th, y to the 2nd to the 3rd over x squared y to the 4th. Again, distribute. See how y doesn't have an exponent? That doesn't mean that it's 0. It actually means that it's 1. So keep that in mind. So I'm going to simplify the top. X to the 15th, y to the 6th, and the denominator. X to the 8th, y to the 4th. And it's to the 4th because y has that invisible 1 power, and then 1 times 4 is 4. And then we're just going to subtract. 15 minus 8 is 7. 6 minus 4 is 2. And this junk up here just equals this nice, much more neat version underneath. All right, well, that was 21 minutes. I'm so sorry. I really was hoping that I could get it done a little bit faster, but it's still better than an hour of class. You have a 10-question assignment that I'm going to post the same time that I post this video, and I'm going to post them on Monday, not tonight, Sunday, Monday. I need to remind myself to post it tomorrow. But yeah, I hope this helped. I will see you guys on Wednesday. Bye!